they got
important.
Hello, sir. You are not audible. Hello, sir. We can't get your voice. Hello, sir. We can't get your voice.
Yeah. Okay. I am not muted.
Yes, sir. Now you
Hello.
are audible.
Hello.
मी जातो खाली.
Am I audible now?
Yes, sir.
Yes, sir. Yes.
Okay. Thank you.
Yes,
Thank
sir.
you. There is something. Okay. Okay. The technical problem is that I think so. So I'm sorry for that. Now I'm sharing again. After this, it was completed, I think so. Hello. Hello.
Yes, sir. This
Oh.
slide was explained, sir.
Okay. Thank you so much. Okay, thank you so much. So, in the swim bladder, it is actually the habitat of the parasite, which injures various food materials, including blood and other tissues. So, gross pathological lesion and hemorrhage spots of the host due to the Dyzenian infection are reported. So, what type of pigmentation are found there? Okay, you can find there. So yeah, isoparetic is oily distributed, you know that, and causes the glycogen deficiency of the body of the koala wat. So there is a background sound is coming.
तुझं बंद झालं अगं काहीच दिसत नाही
There is the background
येऊ
sound is
नका.
there. So,
I request.
hello.
Hello.
Am I audible?
All the participants. Yes, you are audible. But I request all the participants to keep your voice.
Oh, thank
Madam, you
you.
can mute them. You can mute them all, except the audience. You can from the controlling from the Zoom control. You can control them.
Okay, okay. Now, the intermediate host, that is the Oryctes, Singhala, Notopteras, Ophiucephalus, major carps, okay, edible fishes, which where the parasites are encysted within the muscles, accumulating blocks of black pigments of the cyst, all causing black spot diseases. So such manifestation of black patches in the muscle and viscera renders the fishes unsuitable for human consumption. So thus causing the heavy economic loss. The parasite utilize one particular freshwater pulmonate snail, that is the primary host, and the first intermediate host, that is the Indoplanorovis exhaustus, where they also develop the pigmentation. Now, this is our field study, where this is the Mukutmanipur research area, Mukutmanipur Dam Reservoir, that is in the Bankura district in West Bengal, Kongsabati Dam, Kongsabati Reservoir, where total life cycle is completing there. In the Indoplanorovis exhaustus, mistus, and Walawat 2, all are present there. So they are completed their life cycle, and huge amount of infections, infected fishes are there. So we collected the parasites from there, and also from the local fish market, which are coming from various states in Calcutta. So the pathological situation, what is happened within the fish, is the swim bladder, the parasite within the swim bladder, make it black spot disease in the liver and the fish. This is the cyst wall within the intermediate host. This type of pathological features you can find. So from this point of view, so what is the general opinion regarding Helminth parasite? You have already known that they absorb glucose, stored it as a glycogen, and a rate of what is the rate of consumption of glucose or glycogen? We don't know. What is the stored glycogen? We don't know. What is actually the glucose content or free glucose in the parasite? We don't know. And what is the energy expenditure, which again depends upon the activity of the ward during the particularly egg-laying time, how they fixes the carbon dioxide, or what type of metabolic pathway they follow, we don't know. So in our first line of investigation, the adult parasites of Isopararchis hypsilobacter, during the study of some aspects of carbohydrate metabolism. So following phases we considered. Number one, glucose is the primary source of energy of parasitic helminths. The quantification of free glucose is very much essential for the live parasites, and how they utilize the glucose being in vitro starvation is also studied. We places the parasite in the in vitro culture media, and we studied that the how they consume or how they utilize during the starvation period. We have also studied and glycogen, how much amount of glycogen is reserved. It is the polysaccharide in the parasites, and how the glycogen is utilized during the in vitro culture system. We also studied, and metabolic pathway, carbohydrate metabolism, either glycolytic or TCA cycle or glycogenolytic pathway, which pathway they followed, and what is the situation of the enzyme and substrate level. We also studied here. Now, phosphoenol pyruvate, we already discussed here. The phosphoenol pyruvate is the key glycolytic substrate from the phosphoenol pyruvate, what type of metabolic pathway they followed, what is the ratio of pyruvate kinase and phosphoenol pyruvate carboxykinase, what is the situation of oxaloacetate, malate, pyruvate, lactate, to evaluate the pathway down to the phosphoenol pyruvate. And TCA cycle enzyme also actively present in the parasites. Therefore, the three main TCA cycle enzymes we also assay during our study in case of fresh parasite and also during the starvation period. What is the situation? So, final question is that what is the end products of the carbohydrate metabolism, from where we can decide what type of metabolism is going on within the parasite during in vitro condition and within the fish body. Because after mortality of the fishes, parasites are also alive much more days, near about 1 month. So that is very much interesting features for studying these parasites. So we collected parasites, then starvation experiment. We put that parasite in the phosphate buffered saline solution with antibiotics. We prepared that extract, tissue extracts for the enzymatic assay under -20 degrees centigrade in cold room, and also utilized cold centrifuge for the enzymatic assay. We utilize the UV spectrophotometer under the cold room. There is no degradation of the enzymatic reaction, and also the chemicals were collected or supplied from the Sigma Aldrich company. So there is no question about the authentication of this research. So what type of observations we can found? So these are parameters we have taken in our study. So glucose content, that is a primary source of energy. Glycogen, how they stored the glycogen or polysaccharide for their rest purposes. So glucose is very much low. I have already told in the previous slide, very much low, 0.776 milligram percentage. But glycogen is much more because it is the major source of energy they stored in their muscular system, 5.127 milligram percentage. Glycolytic enzymes we have studied here, hexokinase. You know that glucose first steps is the hexokinase enzyme, glycogen phosphorylase enzyme, which break down the glycogen to glucose 6-phosphate. You already know that. And phosphoglucoisomerase is most important enzyme. Pyruvate enzyme which transfer from phosphoenol pyruvate to lactate to lactate. So there is the lactate dehydrogenase enzyme. And for CO2 fixation pathway, FCK is more important enzyme. So we studied much this about most important enzymes responsible for EMP pathway and TCA cycle enzymes. 3 important enzymes: ICDH, isocited dehydrogenase, you know that, alpha ketoglutarate dehydrogenase, and malate dehydrogenase. So the glycolytic enzymes, TCA cycle enzymes, and major end products, which depends on what type of metabolism or is going on during the life condition of that parasite in the host and in the in vitro condition: phosphoenol pyruvate, lactate, oxaloacetate, and malate. So what type of investigation? So we are finding here the glucose. So when we put these parasites in the starvation period, up to the 72 hours starvation period, we can find that they utilizes their glucose. That means degradation of glucose condition. Okay, glucose content is gradually slowing down from these data, and from this graphical representation, we can find that the control parasites, there is 0.776 milligram percentage glucose is reduced to 0.155 milligram percentage within 72 hours period, which is much more degraded after 24 hours period. So they are utilizing glucose for their energy purposes. That means for their living purposes. So glycogen content, glycogen is the main stored enzyme. We have know that already. In the fresh parasite, glycogen is 5.127 percentages, which also in the percentage in the after 6 hours, 12 hours, and up to the 72 hours, it is reduced or degraded to 1.683 milligram percentage, and drastically decreased after near about 24. So up to the 24 hours period, there is very much slowing down, not so gradually decreasing, but after 24 hours, they utilize their glucose and glycogen much more for their survivability. So they're utilizing their glucose and glycogen during their starvation period. Now, if they utilize their starvation period, glucose and glycogen, so we also finding out them that in the culture media, they also releases glucose through their plasma membrane. That means the glucose leakage is also taking place. So what type of glucose leakage? When we studying about that, when we taken the culture media, there we can found some glucose is also secreting or leakaging occurs from the parasite. So we have also studied there how much amount of glucose is leakaging is taking place in the parasite. So it is found that from the beginning to the 24 hours to the 72 hours, the leakage of glucose is increasing trend from 4% to 12%. That means there is the cell membrane type is also there is the passage. That means transporter mechanism is also taking place throughout their parasitic body. So they also leakage the glucose from their body in the culture media. So next, we want to say that now, if there is glucose leakage occurs, so what the mechanism they uptake the glucose? Okay, how much quantity of glucose they can uptake during the starvation period? Okay, so after starvation of 6 hours, we are or after starvation of 12 hours, 18 hours, 24, and so on. So after starvation, we place the parasite in the glucose medium. So at first we placed it 100 milligram per DL. So we finding out that they are taking up glucose from the glucose medium from 11 milligram percentage. That means 11 milligram, that means rate is 0.122 to 0.146 milligram per fruit per hour. Okay, so in the control fruit, but in case of experimental fruit, that is means starved fruit, that is much more. That means 0.111 to 0.145 milligram per fruit per hour. If we place the parasite from the host to the culture media and from starvation period to the culture media is more or less same. So there is no differences of uptake rate found in the glucose uptake in case of parasite. But if we added, so this is the uptake rate, you can find it, is very much within the 20 hours, the uptake rate is high and then it is gradually saturated. That means they don't take much more glucose after that. But one interesting feature is that if we added BSA in the culture media, 100 milligram glucose with BSA 10% BSA, So the rate of uptake is increasing. Rate of uptake is increasing gradually much more than the control experiment, or in simple glucose plus BSA, because protein is the carrier protein acts on the parasite. Parasites protein helps to accept that protein. So 10% BSA if we add it with that, so increasing rate of uptake of glucose is taking place in this parasite. Same also you can find the 200 milligram percentage. So there is a saturation level. We can also find that 200 milligram percentage, find that within 20 hours to 40 hours or 50 hours, much more glucose uptake is taking place. Then it will be saturated. Okay, that means 0.160. In same things is found that not much more that takes place. Then 10% BSA. So taking rate is much more, uptake rate is much more with adding of 10% BSA. And we also studied about the 300 milligram percentage glucose. We also can find that the saturation level is same. Saturation level is same in regarding the 100 milligram glucose percentage, and the uptake rate will be high after adding the 10% BSA. 10% BSA, it is high, much more. So protein act as a growing factor or uptake factor, enhancer for uptake of glucose, which is stored as a glycogen for their future purposes. So for their metabolic pathway, we are now estimating about the hexokinase activity. We know that glucose is breaking down to the glucose on phosphate, glucose 6-phosphate by the enzyme hexokinase. Hexokinase activity is varied between 101.95 to 20.79 varied. In case of normal parasites, that is the after collection, the parasites, their hexokinase activity is 101.95 nanomole per minute per microgram protein, milligram protein, which is gradually decreasing from this graph. You can find that this decreasing activity of the hexokinase with the increasing time of starvation period. That means hexokinase is utilizing during the starvation period for breaking down of glucose. Then our another enzyme is a glycogen phosphorylase. Glycogen phosphorylase is the enzyme which is responsible for breaking down of glycogen, and also as a store of glycogen, helps in the storing of glycogen, which shows the opposite role, that is the glycogen phosphorylase A activity is gradually increasing within the time of starvation period, because they want to store the glycogen very much rapidly during the starvation period for their survivability. So the glucose, which is decreasing in our study, that goes to the storing of glycogen through the activity of glycogen phosphorylase A. That means active glycogen phosphorylase. Now, phosphoglucose isomerase is another enzyme of Emmett-Mahorov pathway, where we can finding out that it is decreasing, activity is decreasing from 29 to 19 nanomole per minute per milligram protein. That means phosphoglucose isomerase is helping. That means isomerization process is going on in also parasite as vertebrate tissue, vertebrate metabolism. Then we want to know about that pyruvate kinase. Pyruvate kinase is main turning point enzyme which breaking down the pyruvate, okay, from phosphoenol to pyruvate. So pyruvate kinase enzyme also degrading or reducing according to the time intervals. That means during the starvation period, pyruvate kinase also decreasing, showing the decreasing trend in this parasite from from the fresh parasite to the starved condition. So pyruvate kinase activity is also much more in case of parasite. Then lactate dehydrogenase. That means lactate is also produced in this parasite. Lactate dehydrogenase. Lactate dehydrogenase is drastically, gradually much more degrading. That means pyruvate is degraded to lactate. So lactate is the main end product we can find here. So production of lactate, that means pyruvate is degraded to lactate by the enzyme lactate dehydrogenase. So lactate dehydrogenase enzyme is the most important enzyme for breaking down of pyruvate to the lactate. But the lactate is not reutilized for the storing of glucose in case of parasite. It is most important things which is happened in case of mammals. So lactase acts as a end product in case of parasite or trematode. Now we want to come to the things about that phosphoenol pyruvate carboxykinase activity. Phosphoenol pyruvate carboxykinase, which is the turning point from phosphoenol pyruvate to the oxaloacetate. That is phosphoenol pyruvate carboxykinase activity is much more okay, now very much increasing from 172 to 1545 nanomole per minute per milligram protein during starvation period. So during starvation time period, FCK activity is increasing. Very interesting features about that. FCK is very much active and increasing during starvation period because CO2 fixation pathway is much more active. Though the parasite living in the aerobic condition, highly oxygen-rich condition, they show the another pathway, that is the CO2 fixation pathway, that means anaerobic pathway. That means switch over from aerobic to anaerobic during starvation period. Now, TCA cycle enzyme, what is the fate of the TCA cycle enzyme? So TCA cycle enzyme, we are finding here that the ICDase enzyme, ICDase is the NADP plus, that is also present. That means TCA cycle enzyme, that means TCA cycle is also evaporated 572, which is also gradually decreased from first 24 hours. It is much more degrading. Then after this is very much gradually, so 151 nanomole. Now same things also you can find in alpha beta dehydrogenase activity from high level to lower level. They are going down. Then MDH, malate dehydrogenase activity, also same things from high level to low level. So in TCA cycle enzyme, that means TCA cycle is operated through the from acetyl CoA, which enters into the mitochondria, ICDase, alpha ketoglutarate dehydrogenase, and malate dehydrogenase. But phosphoenol pyruvate, which is the key point. What is the fate of the phosphoenol pyruvate? Phosphoenol pyruvate is found there very much quantity, 0.556 micromole, not in the nanomole. Huge quantity of phosphoenol pyruvate that divert through the FCK and PK. So FCK, we found there that FCK is increasing for degrading of the PEP content to the oxaloacetate. Is it clear? I think so. Then We want to name the pyruvate. What is the pyruvate content? That is the end product. We want to study about that. What type of end product? End product is increasing after metabolism of carbohydrate. End product is the higher amount organic acids as end product. Pyruvate content is increasing after starvation period. Then lactate content is also increasing during starvation period. Then oxaloacetate content also increasing during starvation period. All the end products are increasing. Find it. It's very much clear here. Malate also increasing in huge amount during the starvation period. That means from the PEP through the PEPCK, the CO2 fixation pathway, that reverse TCA cycle is highly operative in case of isovaleric Hypsilobacter through entry of oxalic acid to succinate. Now, this PK and PEPCK ratio determine the carbon dioxide fixation. So the relative importance of PK-PEPCK differ in different elements and various environmental conditions. And this ratio of PK and PEPCK told us or finding out that concluded us that what type of carbohydrate metabolism is persist in this nematode. So we want to say about that. We can find here. Now this is the you can there. So phosphoryl CO2 fixation, PEPCK through oxalic acid. We have already established there. End product malate, we can find pyruvate. Also there the lactate we find there. Now, so most parasitic helmet there the PK-PEPCK ratio. Okay, PK-PEPCK ratio. If we find there the PK-PEPCK ratio is in between 0.1 to 0.008. In case of phase parasite, this is 0.104 PK-PEPCK ratio, and after 72 hours, we can find there 0.008. So this ratio, those parasites rely primarily on glycolysis, have a PK-PEPCK ratio range of 2 to 10, and while those parasites which rely on carbon dioxide fixation have the ratio of 0.1 to 0.05. So here in our result, you can find there the CO2 fixation pathway is more active in case of isoparatous Hypsilobacter. Okay, now we want to say that from these results, what we conclude that the results shows that it can be concluded that due to the high energy demand of the parasite, because of the effect of in vitro starvation, the process of glycolysis, glycogenolysis, CO2 fixation, TCA cycle pathway got affected on the expense of the other metabolic pathways of glucose utilization by regulating some key enzymes of the carbohydrate metabolic pathway. And glucose and glycogen are the primary source of energy, which are depleted during starvation period, are regarded as the main substrate for carbohydrate metabolism in the food, which are utilized through the glycolytic and glycogenolytic pathway. The enzyme like hexokinase, glycogen phosphorylase, phosphoglucose isomerase, pyruvate kinase, lactate dehydrogenase are the key enzymes of glycolytic and glycogenolytic pathway are affected during starvation period. The presence of TCA cycle enzymes like ICDH, alpha-ketoglutarate dehydrogenase, malate dehydrogenase are more active in fresh water, which are inactive, which are indicative of active TCA cycle also persist in this flu and affected during starvation period due to the insufficiency of oxygen. So PK-PEPCK branch point provides an important clue for the switch over to the phosphoryl pyruvate to oxalic acid pathway for the carbohydrate metabolism. So the PK-PEPCK ratio shows that during starvation period, PEPCK activity got higher, which indicative to the CO2 fixation pathway is performed during the starvation period. Oxalic acid is reduced to malate, whereas pyruvate is indicative of lactate production as an end product of anaerobic carbohydrate metabolism. But the pyruvate content is high in this parasite is regarded to be the major end product of carbohydrate metabolism in this group. So the glucose uptake rate is higher from high concentrated glucose media, depict that glucose is transported through passive transport and also indicates that the main source of energy is glucose in this parasite. So what is the impact of this work in the scientific or technological potential in this country? The parasite mode of life leads to different types of parasitic adaptations. The carbohydrate metabolic or catabolic pathway it follows plays an important role for such host-parasitic interactions. The present parasite is a digenetic trematode living in the swim bladder of Alago-2, the oxygen-rich biotope. In the present work, it is observed that the parasite, though live in the oxygen-rich environment, possesses the enzymes necessary for CO2 fixation, which means it mostly depends on anaerobic mode of respiration wherever it is necessary. The knowledge gathered from the study may help in future to finding out the weak point in the metabolic pathway for its blocking, which may be necessary for its control. These are the publications in various publications papers. So I feel deeply honored to have been invited here today as the research person for this national conference organized by the Department of Zoology and Microbiology. I convey my gratitude to the principal, convener, coordinator of the national conference and also held by D.B. Bhosle College, Gurgaon district, Satara, Maharashtra, and also very much thankful to Professor Mane sir to giving me this platform. Okay, thank you everyone, and thank you to the organizing committee, convener, coordinator. Thank you, sir.
Yeah.
Thank you, sir, for giving your valuable insights on carbohydrate metabolism. Now, session is open for question answer. I request to all the participants kindly propose your questions in front of experts. I request all the participants, if you have any questions, then raise this.
Dr. Bera, can you hear me? Am I audible? Dr. Bera?
Yes, sir. Yes, sir.
Dr. Bera? Am I audible? Bireshwarji? Bireshwarji, can you hear me?
Sir, please unmute your mic. Bera, sir. I think your mic is unmuted.
Bireshwarji? Am I audible? Bireshwarji? Dr. Bera? Anyhow,
Mane, sir, you are audible.
yeah, I am audible. I am audible, but he is not receiving our call.
Because his mic was muted.
Yeah. Bireshwarji? Anyhow, it was a very nice presentation, very fruitful one.
Hello.
Yeah, Bireshwarji.
Yes.
Yeah, it was a very nice presentation what you have given us,
Thank
which
you,
will
thank
add
you.
to the knowledge of our students of UG and PG. Really, it was a wonderful
Yes.
session.
Thank you, sir.
Thank you. Thank you.
For your
Thank you.
generous. Okay, sir.
Thank you.
Okay,
Thank you, sir. Thank you.
Thank you. Thank you, everyone.
Okay.
Thank you very much, sir.
Thank you, ma'am.
Now I request chairperson of this session, Dr. Mrs. V.R. Chauhan, Principal Shri Vijay Singh Yadav College, Pet Vadgaon, Kolhapur, to deliver his talks. Sorry, her talks.
Okay.
Thank you. Thank you, madam. Let me first congratulate the management, the administration, and the organizing committee of this national conference for organizing such wonderful talk. Let me wish a very good luck for the participants in this Innovative Trends and Biological Research National Conference held today. And let me then give my some random thoughts on the presentation of Dr. Bireshwar Bera sir. Sir has given an excellent talk which is well organized, and his title of the talk was Carbohydrate Metabolism in Trematodes with special reference to Isoparaphrys hypselobargi. Sir has introduced this topic in a very nice way, where he first gave the history of this parasite, the classification and the other minor details of this parasite, and then how this
Excuse
parasite.
me.
Yes.
Hello.
Yes.
Can you repeat, please? Can you repeat, please? Hello.
Yes, sir.
Hello. Hello.
To whom you are speaking, sir?
Yeah, yes.
Yes, yes, yes.
Can you repeat? Can you repeat, madam?
Yeah. See, I was telling that how you have given a very nice talk, and you started your talk with a introductory way, and you introduced this parasite in a very nice way. Usually this area is being neglected, and
Yeah.
as this is a parasite of a very important edible fish, we are
Yeah.
quite interested in its biochemistry, physiology and all this. And
Yes.
you choose this topic
Yeah.
which is very crucial as far as the parasitism and the pathophysiology of this important parasite is seen and concerned. As
Yeah.
this fish is a edible fish, which
Yes.
is known for its soft flesh.
Yeah.
This area is to be understood very widely and correctly.
Yeah.
And your talk was well organized, stating the importance of the organism and
Yeah.
how it is working for the metabolism of carbohydrate,
Yeah.
even though it is an endoparasite or attached to the swim bladder of this organism.
Yeah.
What are the different enzymes working for the carbohydrate metabolism? What are the end products? How it is going for the anaerobic and the aerobic respiration,
Yeah.
aerobic conditions, and even you have studied a lot about the enzyme. Enzyme percentage, enzyme working and all this. So no aspect of this area is neglected while you have worked on this unit. And let me first congratulate you for this wonderful talk, which was very well organized and quite informative in lucid language and good prepared slides. So I once again congratulate the speaker as well as the listeners and the organizers for this wonderful talk. And I wish a very good luck for the forthcoming lectures to be organized in this hybrid session of this national conference. Thank you once again.
Thank you, madam, for your generous lecture, for your generosity, and for your kindness. Okay, thank you, madam.
Thank you.
Very much welcome. Okay, thank you, madam.
Thank you so much, ma'am. Now I request Mr. A.S. Bansode sir to give vote of thanks. Mr. A.S. Bansode sir.
Good afternoon, everyone. It has been such an honor to be a part of this wonderful event. On behalf of Royal Education Samsthas, DP Bhosle College, Koregaon, I would like to express my sincere vote to our chief guest, Dr. Bireshwar Bera, Assistant Professor, St. Joseph College, North Point, Darjeeling, who accepted our who accepted our invitation and and guiding us. Also, I would like to thank our chairperson, Honorable Dr. V.R. Chavan Madam, Principal Sri Vijay Singh Yadav College, Pet Vadgaon, and being here as chairperson. Thank you.
Thank you very much, sir.
Thank you, sir.
Thank you.
Now session first is over here.
Okay.
Now we'll shift it towards plenary session 2 with introduction of resource person.
Okay, thank you.
Now, Dr. K.J. Kamay to introduce our today's resource person for section 2nd, Professor Dr. Meghnad G. Joshi, Professor and Head, Dr. D.Y. Patil Medical College, Kolhapur, and Chairperson Professor Dr. A. Deshmukh, Head, Department of Zoology, Shivaji University, Kolhapur.
Good afternoon all. Speakers, delegates, faculty members, and all the participants. It gives me immense pleasure to introduce you to all our resource person of the session, Professor Dr. Meghnad Joshi, Professor and Head, Department of Stem Cell and Regenerative Medicine, Dr. D.Y. Patil Medical College, Kolhapur. Dr. Meghnad Joshi completed his PhD from the Department of Zoology, Shivaji University, Kolhapur in 2006. He joined Karolinska Institute, Sweden as a postdoctoral in 2007 to 2008 for fetal and adult hepatocyte transplantation studies. In 2009, he has been appointed as a visiting assistant professor by Kansas Medical Center, USA from 2010 to 2012. He has worked as the lab director at Stem Cell Biological Private Limited from 2011 to 2012. Presently, he is working as the professor at the Department of Stem Cell and Regenerative Medicine, Dr. D.Y. Patil University, Kolhapur. He has 2 ongoing projects in his lab, 6 PhD students working under his guidance. He was a member of Zoology, Shivaji University, Kolhapur in 2018 to 2020. His area of research is stem cell and stem cell transplant, tissue engineering, and 3D bioprinting. He has published more than the 46 papers, 4 book chapters, and 7 patents. With this brief introduction, I will come today's resource person of this session, Professor Dr. Meghnad Joshi, and request to guide the students with these valuable words. Then I would like to introduce today's chairperson of this session, Dr. A. Deshmukh, Department of Zoology, Shivaji University, Kolhapur. Currently, he is working as head, Department of Zoology of the Shivaji University, Kolhapur. Sir has started the step of his career as a lecturer from the Amravati with outstanding achievements. Dr. Deshmukh is recognized research guide of Shivaji University. He has 2 PhD students working under his guidance on the path of successful professional career. His scientific accomplishment as follows. He has attended and presented research papers in many national and international conferences, published 39 research papers in various journals, and successfully completed 3 major projects. With this introduction, request Sir to chair the session with his valuable words. Thank you.
Thank you so much, ma'am. Now I request our second resource person, Professor Dr. Meghnad G. Joshi, Professor and Head, Dr. D.Y. Patni Medical College, Kolhapur, to guide all the participants with his valuable words. I request Professor Dr. Meghnad G. Joshi to guide the participants.
Yeah. Good afternoon, all. I think I'm audible. I would like to, administrator, please mute everyone so that I don't get disturbance during the lecture. Good afternoon, everyone. I would like to thank organizing committee for giving me opportunity to share my work. Just a minute, sorry. Share my work. So today I'm going to discuss about recent advancement in the regenerative medicine field, and I'm also going to introduce you to the area of stem cells, and then a little bit about the application part, what type of applications which we do it in our lab.
Hello, sir. Sir, you are sorry, you are muted. Please on your mic.
Hello, I'm audible?
Yes, sir, you are.
Okay, so it is very important that we should understand how the stem cell research can be useful in clinical settings, at the same time research. Most important aspect in studying stem cell is they will be able to give us insight of developmental biology, because as we all know that two haploid cells, when they unite, they start to divide, and the development process starts. So it is very important that if we study the basic cells which trigger the development, can be helpful to give us the idea about how development process happens and how those organ differentiation or how organs are formed can be studied. Most important aspect in a clinical setting that whenever you transplant stem cell, they able to replace the diseased tissue and they renew themselves, so the organ can be rescued. Of course, in this era where people discover different drugs, different molecules, and these stem cells can be a useful marker in identifying how these different drugs or molecules can react, and they can actually help us to minimize the lab animals requirement. And most important, whenever a disease occurs, there are certain genes which are trigger or they are responsible for disease. So these stem cells able to help to understand the genetic machinery, how the disease occur or how you could actually reverse the disease. So these are the important aspects of stem cell research. So there are some unique characteristics of stem cells because in our body there are cells which are constantly dividing, but when it comes to stem cells, they have a peculiar characteristic. Whenever stem cell divide, they renew themselves. That means once the stem cell divide, one new stem cell is generated. At the same time, one cell can be specialized according to the need or organ. That means if the stem cell is divided in the liver, it will form a hepatocyte. At the same time, it will keep her stemness in the organ, so that whenever there is a need of cells, it can provide. So in other way, whenever the stem cell divide, it remain undifferentiated form. So the stem cell characteristics is been achieved, and thus the specialized cells are formed, that is organ specific. Wherever the stem cell is dividing, depending upon the niche, it has potential to differentiate or become a specialized cell. So these are the important functions of stem cells. First is the plasticity, that is potential to change to cell types like nerve cells, hepatocytes, islets. Homing, that is able to travel at the site of injury. So whenever an organ is damaged, stem cells able to home themselves at the site of injury. And engraftment. Engraftment is a potential of cell. Wherever the cell is transplanted, they will able to integrate or unite at the site of injury or in the tissue. So these are three important functions of stem cells. So there are several types of cells which are found in the body, and depending upon the source, these stem cells can be classified, or in other words, the potency of stem cells is defined with the age. So stem cell potency can be classified according to the age. So at the top, whenever we're talking, is the totipotent cell. So this is found in a few hours after fertilizing. So these cells have potential. Whenever you isolate those cells, they single cell able to form a complete embryo. So this is the characteristic of a totipotent cells. Now, as the cell ages, the cell become pluripotent, and these cells can be found in the inner mass of blastocyst or embryonic cells, or in adults, wherever we are talking about induced pluripotent cells, where any adult cells can be reprogrammed to form a pluripotent cells. So these are the pluripotent cells. The peculiar characteristic of pluripotent cells is they able to differentiate into 3 germlines. Now, the pluripotency, when the cells become pluripotent, they lose their characteristic of becoming reprogrammed cell, like how totipotent cells can form. Totipotent cell able to form a complete embryo, but this characteristic is lost during the development process, and pluripotent cells can only differentiate into 3 germ cells. Now, as the age progresses, cells become multipotent. That means they able to differentiate into single progeny. Like if the cells are from ectodermal, these cells able to differentiate into ectodermal origin, or mesodermal, if you could say that these cells can able to differentiate into different type of mesodermal origins. These cells can be found in cord blood cells or bone marrow cells. And another class of cells is called unipotency. Now, this unipotency is only characterized to the tissue-specific cells, or if you could identify a particular class of cells present in liver or kidney, these cells are called unipotent cells. And these cells can be found in adult cells. Now, little bit about the sources of stem cells. Their most important source is embryonic stem cells. here in embryonic stem cells, you could actually isolate totipotent cells, pluripotent cells. In fetal cells, you will be able to isolate pluripotent cells. In adult cells, of course, there are multipotent or unipotent cells you could isolate. Now, these are the different sources like umbilical cord blood cells, cord blood, cord tissue, placenta, brain, olfactory or nasal passage, bone marrow, adipose tissue, intestinal lining, skin, surface of eye, muscle, peripheral blood, and urine. So these are the different sources of stem cells from adult origin. So this is the animation which integrate how the potency of stem cells is classified and the age of the stem cells. Now, as I discussed, embryonic stem cells are always like a totipotent cells, and these embryonic cells can be found only 1 to 3 days embryo. So if you have isolated cells from this embryo, you could actually form a complete new embryo after isolating a single cell. Now, at the lower end, there are two triangles. First is progressive loss of potency, and the yellow one is a developmental stages. Now, if you could see, you have the highest potency for embryonic cells, but at the same time, whenever we are talking about the developmental stages, that means or development or specialization in terms of functionality, this is very low. So these embryonic cells have a higher potency, but functionality is very less. So as age passes, these cells become pluripotent, and you could actually isolate cells from the fetal tissue, and the pluripotency can be achieved, or you could actually isolate pluripotent cells at the age of day 5 to day 14. So these, whenever you isolate cells from day 5 to 14, a single cell has a pluripotent characteristics. To summarize, these pluripotent cells have ability to differentiate between 3 germ lines. Now, as aging of cells result, these pluripotent cells become multipotent, oligopotent, or unipotent. Now, the age of these cells can be of 9 months to till the human. So highest is say 100. So at the first a minimum age of adult cells which can be found in cord blood. So you could say that the age of the adult stem cells derived from cord blood is 9 months. And they have good pluripotent stem cells that can be useful for a variety of treatments or research. So these cells can be found in bone marrow in adult. At the same time, they can be stem cells can be found in lung, heart, liver, kidney. So all the organs, the living organs, should have stem cells which help them to recover through the damage. So at this, let's discuss a little bit about the developmental stage, that the yellow triangle. Now, if you could see that the functionality of cells is very low at the embryonic stage, and cell become more and more specialized in terms of function at the adult stage. So these two triangles are inversely proportional, that if the cell has the highest potency, the differentiation or functionality of the cells is less. As you age, the functionality you have higher. At the same time, the potency loss is seen in the stem cells. So why the stem cells are so valuable for in the present situation? A little bit to discuss about the pluripotent cells or tissue-specific stem cells. Now, there are several applications which we are which we are actually now into clinical reality. One of the most important is cell therapy, because you could actually use those tissue specific stem cells to rescue the organ. And this is a new era in the medicine, where instead of allopathic medicines, actually regenerative field able to help with the living cells so that they can take over the function of damaged tissue. Of course, research in terms of genetic, molecular, biological control to study the tissue growth, development related to disease. So we actually able to understand in the Petri dish about how the disease progression happens. For example, cancer, what are the responsible genes which are triggered during the disease condition. Of course, as I have already discussed, it is easier for us to understand how the newer drugs can respond in the body, or how these drugs can create the response in the body. To summarize this slide, we have it is like no one stem cell type fits for all applications, and research must continue using all types of stem cells. So there is not something like a magic where a single stem cell able to carry out a lot of functions. So depending upon the disease, depending upon the application, the types of cell different, and it can be achieved by the customized protocol. So as a very layman's question is how you are defining stem cells, because whenever you look at in the cell culture, both the cells or stem cells or any adult cell look like same. So how you are going to characterize them or differentiate them between the stem cell and adult cell? So if you want to define the stem cell, you need to label them, or you need to identify them with cluster of differentiation markers. That is, in simple words, it's called CD marker, and it is considered to be gold standard. And every stem cells, depending upon the source, stem cell express different CD markers, which I'm going to show you in the coming slides. So in simple word, you have every cell has a CD marker, and you define an antibody which has a fluorochrome, and then you will be able to identify these cells either with a fluorescent microscopy or bright field microscopy, or more sophisticated instruments such as flow cytometer. So you will be able to identify the cells. So in the simple word, these are the two photographs of cell hepatocytes. So these are the adult hepatocytes, and these are the fetal hepatocytes. But whenever you are looking at these photographs under the phase contrast microscope, it is difficult for us to identify which one is the stem cell and which one is the non-stem cells or somatic cells. So this is, in a simple word, if you could label those cells, you will be able to identify between the normal and stem cells. So this can be achieved by phenotyping the stem cells. For example, there are different CD markers which expressed by epithelial cells or mesenchymal cells or endothelial. So depending upon the three germ lines. For instance, if you want to identify epithelial cells, the epithelial cells express CD34 or CD133 or CD90. Mesenchymal cells, they express CD271, CD90, CD29, and 44. Or if endothelial cells express CD31, VEGFR2, TIE2, or CD144. So these different markers able to help us defining the population of stem cells. Now, in a simple word, this is a typical flow cytometry characterization of stem cells, and what we do is we stain those cells with different antibodies and check what is the population of stem cells? In simple words, this is CD34. As we know that CD34 is a hematopoietic marker or epithelial marker. So as these cells are mesenchymal origin, they should not express CD34. This bar graph shows that they are negative for CD34 expression. At the same time, if we check if this is CD29, CD44, CD166, and CD73, those cells have positive for these antibodies, and this is how you actually characterize these population with using flow cytometer. You also able to characterize these cells by immunocytochemistry, where you actually see how the cells are expressing. Now, in this picture, I have characterized the fetal hepatocytes by immunocytochemistry, and I have stained it for different antibodies like albumin, alpha fetoprotein, c-Met receptor, CD271, then cytoskeletal CK8, 18, and 19, and as we have done, we have studied hepatocytes, so we have also stained it for hepatocyte antigen, and these are for controls or secondary antibody control for all the staining. So these, for instance, these hepatocytes, hepatocyte characterized for synthesis of albumin. So these green fluorescent shows that the hepatocyte have albumin. Alpha fetoprotein, because they are fetal origin, so these cells express alpha fetoprotein, which is red in fluorescence. Now again, the c-Met receptor, they also express CK8, 18, 19, and this hepatocyte antigen. So this is how you actually characterize stem cells and identify the population of stem cells and what they are expressing in the cell culture. So let's start a little bit with the application part, because regenerative medicine is studied where you could be able to replace diseased organ, and this is the same way we are also working a lot with different tissue engineered and 3D printing products. And these are aimed to develop organs, artificial organs that can be useful for humans. So what we have done here, we have standardized this format using goat kidney, because goat kidney has human size. So we aim to develop something of human size, and that can be translated to the clinical setting. So this is a simple process of tissue engineering. What we do is, first we remove all the cells from the organ so that you have a skeleton. So this is how we have developed a protocol by which you could actually remove the cells, which starts from heparin wash followed by 2% SDS. So 2% SDS is a detergent, and again followed by 1% Tritonix. Now Tritonix is ionic detergent, so it actually removes a lot of impure protein which are stuck there. So you just start with then whatever detergent you need to have. Wash all the things with the distilled water, and this is how after 52 hours, the entire decellularized kidney is formed. So this is how it actually looks, decellularized kidney. Now, in a simple words, we need to check that there is a complete structural integrity of the kidney, because we want to recellularize with different cells. So we need to check how the circulation is in the kidney, and we inject a dye, and actually you could see the angiogram of a kidney, where we could see that all the kidney arteries and veins are restored. This is electron microscopy photograph to show that there are extracellular matrix is preserved. That means there are no cells, but the skeleton is well preserved. We also check it with the help by studying the DNA content. So you start with the control that this is the goat kidney, and during the decellularization process, you actually lose all the cells, and after 52 hours, there are negligible amount of DNA content found in kidney. So of course, say we have developed the graph. Now the purpose of our next study is to use this graph for a xenomodel. That xenomodel means you transplant into 2 different species. So we have prepared the kidney scaffold from the goat, and we transplanted it into the rat kidney. So this is how we have developed a transplantation process. And we have in this picture, if you could see, this white has a acellular goat kidney graft, which is transplanted. And after 30 days of transplant, what we have done is we have harvested this kidney tissue and studied for how whether these scaffold able to recruit the cells, and this can be studied with different staining techniques. Of course, MRI is an important tool where you will be able to see if there is a functional organ, or there might if your transplanted piece has kidney piece has created any problem. So there are both functional kidneys which can be which has taken this MRI dye, which can be easily visualized. So this is just to conclude that there are functional kidneys with this rat. So what we did was we have harvested that kidney graft and then studied for different histological techniques. Here, if you could see. So this is the control. This is a goat kidney, which you have normal structure of glomeruli. There are proximal and distal tubules which can be visualized. So during the decellularization process, if you could see, there are no cells, there are empty glomeruli, there are no cells in proximal or distal tubules, but the entire structural integrity of the kidney is been preserved, which can be analyzed by Mason's trichrome. Then ancient blue, you could actually see glycism and glycans, and trypan blue just to understand the immunological response or whether you have a extracellular matrix. So this step confirmed that the decellularization process has removed all the goat cells, and at the same time the kidney is well preserved in terms of extracellular matrix. Now this is the transplanted scaffold. If you could see, there are, because we have harvested this piece after 1 month, so we have not found the complete structural integrity of a kidney tissue, but there are cells which are recruited at the glomeruli sites, and there are developing cells which able to start structuring the kidney tissue, which can be observed by the different staining. So there are a lot of rat cells. Actually, they come into goat tissue and they started to form a kidney structure. So we have also studied different immunological markers which are very specific to kidney cells. For example, AQP1 staining. So these cells actually represent that the cells, they are differentiating into kidney specific cells, nephrin cells, which actually contribute to integrity of nephrons. So these cells already started to accumulate at the scaffolds. Of course, alpha SMA is related to the smooth muscles, and VEGF, because if there is a regular angiogenesis, that means there are blood supply. That means there are possibility that there will be more and more cells which will be recruited at the site, and the entire scaffold will be recellularized by rat cells. These are few of the scanning electron microscopy photograph of the scaffold. If you could see, their glomerular structure is being restructured. Now there are different type of cells which are specialized. They are being recruited. If you could see actually RBC structure. So there are lot of cells here. For example, proximal and distal tubules, tubular cells are being well organized. So this is just a good sign that the developed scaffold has ability to recruit rat specific cells, and this could be an ideal candidate for the development of a kidney, which can be important to the human size. So in the next slide, I'm going to discuss about 3D bioprinting, because this is a new kind of technology which is actually which can be useful to print organs, and that can be transplanted. So in a simple word, 3D printer is it's like additive manufacturing to create three-dimensional objects from three-dimensional digital information, and three-dimensional digital models are sliced into many two-dimensional cross sections that are then printed on the top of each other. So this is how a simple 3D printing is used. Now 3D printing technology is been very popular because it is easy to use. It is economical to own one, can be operated in office lab homes, equipping students with the skills for the future. It has a very affordable price, and it takes the digital inputs from 3D data and creates the solid 3D parts. So now a lot of designers, engineer, biologists, they actually use this 3D printer to design the products, and it gives a 3D platform for the product. So this is a simple technology which we are using it, which is called FDM technology, and where actually you have a material which has been drive through wheels which liquefies, and this is the nozzle where it actually print at the base. So this is how a simple FDM technology works. So these are the applications of 3D printing. Most important is the medical applications. Now this because of this 3D printer, actually all the anatomical or bone structures can be easily studied for medical students. So this become more and more popular for all the bone defects, and you could actually use or implement those kind of structural things into the research as well as teaching. So there are a lot of medical processes that are already into clinical reality. For instance, if you could see in this picture, so there have been development of customized hearing aids and braces, body parts, including ears, hips, and even organs, and exact proportion to fit the patient. Now it has been done in February 2012, where surgeons successfully implanted the entire titanium jaw made with the 3D printing in an elderly woman. You could actually see, wow, sorry. So if you could see this is also similar kind of application. This is also a small kind of a video clip where you could see that this person has entirely synthetic silicone graft, because this patient had a serious accidental injury. He has entire face was destroyed, and they have formulated the entire 3D printing, which is very similar to skin tone. So the technology has been developed in such a way that you could actually send the CT images from the mouth, from the face, and you could actually send those same to the 3D printer. So you will be able to customize a 3D product which can be of clinical importance. So this is how people are started to use 3D printing technology in the medical applications. So there are a lot of other applications such as dentistry and all those things. And in my lab, we are also working a lot related to 3D printing, and my lab is more concentrating on bone tissues, cartilage, skin. So we have our own 3D printing technology where we able to print different organs. I will come in next slide. So this is how.
Excuse me, Meghna.
Yeah.
Your screen is not visible.
Is it?
Yes.
एक minute. So तुम्ही अगोदरच बघितलंच नाही का?
पहिल्या दोन, आता या दोन स्लाइड मगाशीच्या नाही दिसल्या.
This one you have or nothing?
Yeah, we could see this, but next slide was not seen.
Okay, I will start again. So this is how the medical application of 3D printing has been developed. So this is also one of the example where they have synthesized silicon-based implant, which is exactly fit to the patient face. So this is how this patient has lost eye and a part of jaw during the accident, and the surgeons, they have printed entire new jaw for this patient and the eye, because if you could see, you will be able to customize the entire system of the face. And these are the silicon grafts, they can be easily maintained. Now if you could see, they have customized implants. So this is the flexibility of 3D printing, where you actually able to use the CT scans or MRI images to understand the exact measurement of organs or tissues which you want to do. And once you have those things, you will be able to send these images to the 3D printer, and 3D printer will print same kind of images. As you could see, this is quite aesthetically improved kind of graph, which has been fitted to the person. So in my lab, we have also 3D printer which has been developed in-house, and we have modified this 3D printer to a bioprinter, and this we actually use it for cartilage printing, bone printing, skin printing. And there are so many different kind of applications which we are coming in the future. Today I'm going to discuss a little bit about the 3D printing of bone, and I'll show you a little data. I think this is a newer technology which is coming so fast, and the applications of 3D bioprinting is been very popular these days. So when it comes to bone, they are the rigid structure, they give mechanical supports. So during due to trauma, fractures, degeneration, infection, and abnormalities resulted in long-term deformity. And during such situation, and there are so limited treatment modalities available to the patient, because the injuries due to accidents have a tremendous effect on patient, because you don't have actually alternative in terms of regeneration or in an aesthetic sense. They do correction, but when it comes to quality of life, we still have a lot of limitations. So there are a lot of other autografts can be treated. Autograft is something that you remove from the body and use it for the at the injury site. There are other allogenic grafts which are been derived from animal origin, and they have also complications such as immune rejection or transmission of infection, because these grafts are derived from either bovine or porcine origin. So we don't know many things related to infection or transmission of viral diseases. Of course, there are biological or synthetic scaffolds made up of collagen, fibrin, gelatin, or hyaluronic acid, chitosan, alginates, which can be as a bone substitute. And there are also synthetic scaffolds. So these, even though you have a variety of synthetic scaffolds, still you have limitations, because whenever it comes to synthetic scaffolds, the biocompatibility is the issue, and the other thing is immunological response against the synthetic tissue. So what we have come up here is a biological link, which has all the characteristic of bone, and they are being stabilized in the by the polymer. So this is a 3D printing setup for bone which we have done, and right now it is printing a disc, and this is how it is actually printed, and this is a printable ink which is liquid in nature while you print, and once it is been printed, it become a solid structure, which you could see in this photograph. So this is a typically bone. It has a porous structures, a lot of calcium is been seen, and this porous structure can be used it as an alternative to the or to the replace as the bone. So most important aspect of this bone bioink is it has a liquid structure, and whenever you put it at the site of injury or in the bone, it becomes solid, and it has a good mechanical structure. We have also studied the biocompatibility of it, because I have not presented all the data here, because due to time constriction, I thought it's better that I will introduce you to the area, and I will be able to answer more related to those things. So these are the simple biocompatibility model which we have developed, and it can be easily studied in all some colleges, or because as a zoologist we know much about the chick embryology, and this is how we utilize this chick embryology model for studying the biocompatibility. In this photograph, if you could see, this is the 4th day where we have placed a bone scaffold into the cam area, and we have studied that whether this is biocompatible, or at the same time does this produce any toxic effect to the chick embryo. And we have found that this bone graft is a very biocompatible. It stays in the body till 15 days, and then we have also studied the later part, but we have observed that the majority of this bone is being utilized by the chick. So we have done some scanning electron microscopy photograph of this bone, and we have found that this is a very biocompatible bone structure. There are different cheek cells which are recruited in the bone, and you could see that there are RBCs which are being attached to this bone tissue, and there are different type of cells which are recruited in the bone structure. That this will give us idea that the porosity of this bone is a very important aspect when you are transplanting into a new system. For instance, you could actually see a lot of cells, cheek cells, which are attached at this scaffold. So this is how we hope that this could be another option for the patient with bone defects. So to summarize all those things, we think that developing more refined printers which can print smaller details, thus eliminate the need of to make separate vascular system for the organ, because vascular system is a very important aspect for every organ, because that is how the energy is being provided to all cells. Now, using this technology to print tissue which are strong enough for implantation, because even though we are doing a short study, it is more important that one should go for longer time and study the lifespan of this engineer organ. So this is how we are working right now about to check the durability of these organs in vivo system. And most important thing is regarding the cost, because if we want to translate it to the clinical side, the cost is a major barrier, and there should be more and more simpler ways or simpler ways by which the technology should be cheaper and it should be available to the common man. Thank you. Hello.
Dear Professor Meghnad, it was a very wonderful talk. Now, topic is open for discussion. We can invite a couple of questions. Audience, you are encouraged to ask some questions.
You could actually drop in the chat also.
Yeah. I think there are no questions. So it's a great pleasure.
Thank you so much, sir. Thank you so much. Thank you so much.
There is echo.
Thank you so much, sir.
Nilofer, madam,
Just a minute. Huh, sir?
shall I continue?
Yes, sir.
So it's a great pleasure to listen Professor Dr. Meghnad Joshi. He had given a wonderful talk on a highly technical topic. He started his talk by elucidating the difference between a stem cell and a differentiated cell. He had even given how to identify a stem cell and a differentiated cell in vitro condition, because all cells look very similar under inverted phase contrast microscope, and how CD markers help us to distinguish between a stem cell and a differentiated cell. Thereafter, he had given the challenges of maintaining stem cell in vitro condition. Maintenance of stemness is very essential, and how to maintain stemness in vitro. He had given a very nice explanation. Thereafter, he had given elucidative explanation on stem cell potency, based on potency how stem cells are classified, and as development progresses, how there is loss of potency occurs and how cells are progressed towards functionality in a very beautiful elucidation. Thereafter, he had given a thought on decellularization of bovine or porcine organs, and there is an opportunity in future in medical practices that this decellularized scaffold can be implanted in a patient where there will be recellularization, a hope of recellularization, and there could be a development of a functional organs. At the final stage of his talk, he had given the amazing video of silicon grafted 3D printing, where a patient we have seen that because of the accident, the patient has lost half part of face, and because of the 3D printing, it was even not recognized by all of us that that part is actually a graft which is generated by 3D printing. Thereafter, he had given elucidation of 3D printer which is available in his lab. And finally, he concluded that in recent years to come, this stem cell and regenerative medicine and 3D printing will be a hope for replacement of organs, and there won't be any much requirement of chemical medicines. Rather, the organ which has to be rescued by medicines will be rescued by stem cell and artificial organs generated by scaffolds. So I am very much thankful, Professor Meghnad Joshi sir, for giving a wonderful talk here. I am also thankful to the organizers of this National Conference on Innovative Trends in Biological Science held by DP Bhosle College, Koregaon. Thank you one and all.
Thank you so much, sir. May I now request Ms. N.A. Sheikh to propose vote of thanks.
Good afternoon, all of you. Honorable Principal Dr. Sawant sir, today's our resource person, chairperson, teachers, research students, and all participants. On behalf of Raya Shikshan Sanstha's DP Bhosle College, Koregaon, I feel honored and privileged to get the opportunity to propose a vote of thanks on this session. I would like to express sincere thanks to our today's resource person, Professor Dr. Meghnad Joshi sir, Head Department of Stem Cells and Regenerative Medicine, Dr. D.Y. Patil Medicine College, Kolhapur. It was an insightful session on recent advancement in regenerative medicine, which covered a lot of aspects. Sir, you accepted our invitation, and you delivered valuable information and encouraging our knowledge. I am also thankful to Honorable Chairperson of this session, Professor Dr. A.A. Deshmukh sir, Head Department of Zoology, Shivaji University, Kolhapur, this session for his contribution. I would like my sincere thanks to each and everyone involved in this wonderful session. Without the participation of an audience like you, it will never be successful. I would like to thank our principal, Dr. Sawant sir, of the Zoology, Dr. Nalawade ma'am, Savade sir, our teachers and non-teaching staff, our conference team. My dear student, thank you very much.
Thank you so much, ma'am. Ladies and gentlemen, here our second session is over. And let us take break for lunch and come back after 15 minutes. We'll meet on same link for session 3 at 3 p.m.
Thank you.
Thank you so much all. I request all the participants kindly join the link sharp at 3 p.m. for session 3.